Hello. It was quite a while. I think that there is even no sense to explain myself. So without any further delay, let's begin another lesson of Doomsday heliophysics. There is no sense to discuss every single space weather event which took place since my last upload. It's far too much for a single movie. Instead, I will try to speak a bit about couple interesting activities which I find worth mentioning. And as you probably know, I'm not interested in common space weather events. So here we go. Many of you noticed probably that those scary disturbances of magnetosphere started to appear pretty often on the SWMF plus RCM monitors. I've discussed already a couple of them in my movies. However, until now, I couldn't tell you if those anomalies are caused by errors in the simulation code or if they were real events. Today I will try to change it. As an example, I will use the event which took place in the night between 27th and 28th of August 2017. Let's take a look at it. Do you like the stench of doom? I do. Okay, but as you probably know, readings from SWMF magnetosphere simulations don't have any scientific value without some actual satellite recordings to support them. And this is the right moment to look at couple funky colored graphs which I like so much. First, let's check what was the general space weather condition during this period of time. Those are the recordings of interplanetary magnetic field from ACE and DISCOVER satellites. According to those graphs, there was no activity which could be responsible for the magnetosphere disturbances. On those solar wind density recordings, we can't see nothing abnormal neither. Lucky for us, a clear mark of doom can be seen on the DISCOVER solar wind velocity graph. On the other hand, there is nothing unusual on the recordings from ACE satellite. Shortly, it's not possible to blame any common space weather event for the magnetospheric disturbances on SWMF plus RCM monitors. And this is probably why KP index didn't reach more than 3 during this period of time. However, on the GOES primary electron flux graph below, we can see a visible decrease of density in the geostationary environment, what is a clear sign that some sort of geomagnetic activity was in fact recorded by satellites. There is as well a second event which took place 2 days later, in the night between 29th and 30th of August. In the difference to the first one, this activity was recorded as well by ACE and DISCOVER. Still, it's not possible to identify what kind of known space weather activity it can be. There are some visible disturbances of magnetosphere on the SWMF plus RCM simulations, but not as spectacular as the previous ones. Okay, time to move level higher and look at some really funky graphs from Van Allen satellite's data page. I've marked the time of SWMF plus RCM magnetosphere anomalies with a red line. Graphs on top show the DST and KP index. In the bottom we can see the power spectrum of plasma within the inner magnetosphere. I won't pretend that I understand everything what is presented on those graphs, as plasma physics is nothing more than one of my hobbies. However, even a complete amateur like me shouldn't have any problems to notice that some kind of activity was in fact recorded by both satellites right in the time of SWMF plus RCM disturbances. Of course, it has to be a coincidence. Those two graphs are for us rather important, as they show some clear shifts in the density of oxygen ions within the plasmasphere. I hope that I don't need to explain how important for us is the oxygen. And those graphs represent the densities of protons at low energy bands. Here we can also see some strong fluctuations. Here we can see the densities of low energy electrons. Again, both satellites recorded a bubble of increased plasma density in the magnetotail. I've reduced the timestamp from 3 days to 24 hours, so we can explore the Doom in every of its sick details. Here we can compare oxygen ion spectrograms with electron intensities charts. You should be able to see that the spikes of oxygen ions density, marked with red arrows, correspond with visible decrease of electrons trapped in the Van Allen belts. Here we can compare the density of high energy protons with partial density of particles at lowest energy bands, 30 electron volts. It seems that while the amount of energetic particles dropped suddenly around the midnight, density of low energy particles was higher than before the unknown activity. And now let's look at the recordings from Themis P1 and P2 satellites. It seems that soon before midnight on August 27th, both crafts recorded a visible decrease of plasma velocity, and in this period of time both lunar satellites were located beyond the magnetosphere. Now let's look at the ionosphere. This is the electron density profile reconstruction. For some reason there is a data gap in the tech recordings, but even on the rest of graphs I can point out some strange activity recorded couple hours earlier. On the bottom graph there is also a visible decrease of plasma density in the F2 layer at the time of magnetospheric disturbance. On the Swazi tech map from ISWA, ionosphere was already pretty disturbed, but there was a clear decrease of electron density at the time of SWMF plus RCM magnetospheric anomalies. And finally, here's the response of geomagnetic field. Without any doubt, this event, whatever it might be, was quite geoeffective. However, like in most of unknown activities, effects were recorded only in certain regions of Earth. Now, let's summarize all the data which you just saw. Trying to be just as objective as I can tell you that during the time of this magnetospheric anomaly from SWMF plus RCM simulations, some unknown activity was in fact taking place in the space environment. I don't know, however, if those images represent properly the behavior of magnetosphere. Let's look at the next event which I would like to discuss. As you can probably see, we have here a very spectacular example of magnetospheric doom. For those who can't read, those disturbances appeared on SWMF plus RCM monitors on July 16, 2017. According to the simulation, during this day there were actually two events. First one soon after midnight and second just after the noon. This is the first event. To be honest, this one doesn't look that bad. Second one is much more interesting. But it seems that it was rather short. Anomalies can be seen for around 1 hour. And it seems that it still wasn't the end. I've checked the recordings from the evening and I've found a third event, just as spectacular as the previous one, or maybe even more. I'm pretty sure that if someone would make a painting of this image, it would be considered as a masterpiece of modern art. It would be a great opportunity to research those magnetospheric anomalies, but there is one significant difference between this case and the previous one. On July 16th, space weather activity was very high. There was a strong geomagnetic storm with Kp index reaching 6 points, caused by something what I identified as a CME impact. Look at the recordings from GOES satellite. On 14th of July, you can see an M-class flare and a proton event which started shortly after. CME arrived 2 days later. It seems that the impact caused a rapid decrease of plasma density in the geostationary environment, both of protons and electrons. Here are the recordings from TIMI's P2 satellite. I think that I don't need to point out the CME impact, as it should be completely clear and obvious, just like the ignorance of people who believe in flat Earth. But I wouldn't be myself if I couldn't find anything to spread my fear porn among the masses. According to the recordings from WIND satellite, just after 12 UTC, there was a deep shift in the phi angle of solar wind velocity. Shortly, plasma started suddenly to blow in different direction. But of course, that's not enough to prove anything. Okay, let's move to another case of unknown space weather activity. This time we will deal with something such mysterious that I don't even know how to describe it. Let's begin once more from the SWMF plus RCM simulation. Event which I want to discuss took place in the night between 1st and 2nd day of July 2017. And that was it. I understand that you might feel slightly disappointed. Comparing to some of the previous disturbances, this anomaly doesn't look that interesting. But it's the rest of data which makes it, in my opinion, so special. First, let's look at solar wind parameters, as it seems that just like before, at the time of magnetospheric anomalies, there was some kind of space weather activity going on. But in the difference to previous case, this event doesn't look like anything common. It's not a coronal hole stream for sure, rather something like crippled and partially digested CME. But simply, I have no idea. What matters, however, is the fact that according to the data recorded by WIND satellite, there was a visible shift of solar wind velocity phi angle, just before midnight on the previous day. And in the morning of July the 2nd, right in the time when magnetospheric disturbances appeared on SWMF plus RCM monitors. Notice as well that during this time, WIND recorded a small decrease of solar wind velocity. But the best is about to come right now. Look what was recorded during this time by lunar TIMI's satellites. Here, the sudden drop of solar wind velocity is much more obvious than on the previous graphs. I marked it with red arrows. It was as well connected with a strong shift of IMF orientation, blue arrow, and an increase of plasma pressure, black arrow. Here's a closer look. Something like this is absolutely abnormal, considering the fact that both satellites were still beyond the influence of magnetosphere. But this is not all, as a second similar disturbance was recorded around 14 UTC on the same day. This time the decrease of plasma velocity was even more significant. Both events were recorded by P1 and P2 crafts, so there is no way that it was any kind of error in the data. And to make it absolutely clear, let's take a look at the recordings from geotail satellite, where we can see a backside gust of plasma right in the same time. Probably just another coincidence. If you are a diligent student, you probably noticed already another backside gust which was recorded by geotail 2 days earlier. Sadly, I couldn't find any other data to confirm this event. And finally, let's look at the response of geomagnetic field. As you probably see, there was indeed some quite strong activity during this day, but it doesn't match the timing too well. Anyway, it doesn't change the fact that the recordings from satellites prove nicely the unusual space weather anomalies.